This is a Delem DA-66W, a CNC press brake control. It's currently installed on a JMT AD-S 3100, which is a 10-foot, 110 US ton press brake. This is a Y1, Y2 machine with XR back gauge, and it's got CNC crowning on it standard. We're going to go over the control. It's a 3D viewing control, the 66W. It's just a simple little program. I'm going to back up here. I've got 4 program buttons here. I've got manual screen, program screen, auto, and semi-auto. I'm going to go into program screen here. Just start off with the tooling library. We've only got 2 punches programmed. This is a new machine. I'm going to go in and edit, add a new tool. It's asking me for tool ID. I'm going to say, well, it's 20. I'm going to make this punch 20. Tool description, I'm just going to call this test. It's kind of hard to see this from the angle I'm at. This it's a Willa 815 tool. It's 6 inches tall. Tool angle I know is 30. It's asking me for the length, 2.3. Straight up projection. The back is 0.86. 0.37. I'm going to go back. This angle is not actually 120, it's 135. I'm going to go straight up for 4 inches. The 45 over 0.75. There's our tool. We're going to change data. Tool description, I can name it. This is a 815 Willa. I can name out the name. It's asking me how many tons per inch that tool will take. Well, it's just a safety built in. You know, if I program a part, particular thickness, type, stainless, or the machine will know if the tooling can handle it. Also, if I'm going to have any overloads, it's going to give me warnings. So this particular tool is 34 tons a foot, so that's 3 tons an inch. It asked me for tip radius, just 0.039. Flattening height, shoulder support because it's American type tool. Now program my tool. There's our tool. Die library, same thing. In either one of these, I've basically got unlimited space of tooling I could have. I'm going to edit, add, go to tool number, say 20. Tool ID, say 20. Tool height, say we got a 5-inch tall, it's pretty tall bottom, but say it was 85. V opening, say it was a 2-inch for like quarter. Say 0.12. Say it was 0.5. Right down, auto finish. Auto finish. There's our bottom tool. The same thing as I did on the punch, I can give it a name, tons per foot, flattening height. There's our bottom. I'm going to delete those tools because they're just... Now if I locked the console, I wouldn't be able to delete these. So somebody couldn't come in and do this if he didn't want them to. Machine press beam, it's the height of it. If we do a massive changeover on the machine, we can program a different upper side. Same thing on the bottom table, a huge die block change out, and basically the whole system. Program constants. Right here I can change, control between inch and metric. Language. I've got fairly large database here. languages that we can toggle the control to. Got a material library. I can build, if I get from a metal supplier, I can get my yield and tensile, the characteristics of the material I'm bending. Then when I pull up that material, the machine's going to know the spring back, tonnage, just a lot of characteristics to get, good parts quickly. Program settings, it's just, different ways the machine runs, how the corrections work, enable databases for angle corrections, and just a lot of stuff. Y1, Y2 if I want to do a fade. Flattening offsets, bottoming, force factor right now is set at 3. Production settings. Intermediate R for X is something I like. If the back gauge is going to come over the top of the tooling, it knows the height of the tooling. It's going to raise up 0.3937 on the R, come up to the X position, and then it's going to float back down. Just, if I got a crown setting or something, it keeps the back gauge from ever, crashing, which it would never do with this. Position corrections, I could do a home on the X correction. Closing speeds and calculations. Back gauge finger positions, I've currently got 3 positions, 1, 2, and I've got a 3rd position. I'll show you when I get over to the back gauge on the machine. It's a lot deeper. It allows me to really gauge some deep parts. Adapters, event logging. Maintenance, got 824 strokes, 9.9 hours on this particular machine. Version of software. These different tabs in program. Tool backup from the control to hard disk if I was worried about losing my tools. And then you can back them up just to a USB quickly. Same thing with my product library. I'm going to go back up. Product library. Got these different parts. If I toggle through them, you can see what they are. Also different ways of seeing them. Kind of, folders upon folders of different parts. Edit programs. Product drawings. We go in to draw a product here. Product ID. Say 12. Product description. I'm just going to call it 12. I'd give it a name. 0.073 is 14 gauge. Bending lengths, it was 12 inches. We could be, 100. This particular machine be 100 up to 120 inch. Outer dimensions. I'm just going to draw a real simple part, and we'll sequence it and bend it. 2 inch, and then we're 1 inch 90, and 1 inch up. We're actually down 0.75. I'm going to go back, actually. This angle, negative 35 instead of 45. So I'm going 45, so 2 inch, 2 inch, 1 inch, 1 inch, and back down 3/4. I'm going to go back and change this to negative 35. Now I'm going to pick my tooling configuration. These are the tools that I've got programmed in the machine. So I'm going to go bend symbolization. It's going to search for the best bend sequence. I'm unbending this. It's a 10 bend part. So there's first bend, second bend, third, so on. These little arrows are telling me, flipping my sheet, and my turn it at 180 degrees or 90 degrees or whatever I'm doing. I can watch these little arrows. Makes it nice if you see my shift gauge. See, I didn't like hard part to gauge right there, but machine will do it. There's our part. I can also see this in 3D visualization. See the part. See the product. Just a lot of ways to do it. Now we're going to go and bend the product that we drew in the graphic mode earlier. So I'm going to go to my program screen, product library. Like there's our product. Going to load. Well, let's say I don't remember what my blank length is in that product. Say it was 4 months later. I'm going to edit it, so I need to shear it at 18.061. I can go through all the characteristics of the program. And view it. See 2D. Go through my bin sequence. I can see it. There's a lot of ways to view this. Simple product, I think probably this is the best way. Remember, I can review and refresh myself with the bin sequence. Go ahead and start the machine. Bin 1 of 10. See the control automatically set a retract or flip up. It's our acute angle, -35. I'm watching the bin sequence because I've only bent this part. Took my foot off the pedal, the machine stopped. Again, if I didn't have the graphics, this would be hard to figure out the bin sequence. There's our part. Pretty simple. I'm going to go into manual functions, show over to the back gauge. So I've got control of the x-axis for setup, also r-axis. This hand wheel is what this hand wheel is for. And also do it with the ram and also the crowning. It's a nice way to set up. There we go. And also, I don't know if I programmed an R, but if I go, this is R, X. Also do a negative R. It's all programmable. I got a 30. Okay, we're going to just bend a simple 90-degree bend here. I've got my tooling pulled up, what I've got loaded in the machine. I got my material, just steel. Material thickness, length, or width, excuse me. My air bending, 90 degrees. The machine is calculated 6.1196 is the depth of penetration of the RAM. You give me 90 degrees in that material thickness with that die configuration. It's computed the mute point or the rapid point because it knows the material thickness. 20 inches. I'm going to start the machine. I want just a 1 inch, so I'm going to put the machine in. R axis is 0, so right level with the bottom die. Deflect is 0.2 because of the thickness. Decompression. There's my mute. Then let me check my angle here. Looks like we're half degree open, which I can correct for that. So I'm open, so I've got to subtract, so negative 0.5. And I'm going to get a little, every batch of material thickness, and the yield's a little different, that's why I'm getting move my back gauge back to 2 inches. Now here I'm also going to program a retract because the way I've got that part in there, I'm going to retract back, say, 3 inches. You can see that function. Back gauge retracted. Now we corrected for a half degree in the same material. I don't know if we can see this on the camera, but it's hard to see. See, now we're right on. Just a half degree. Opening. So we got a lot of open right now. Let's say I change this to 1. I'm going to cycle the machine so you can see what it does. And all this stuff in the manual screen is the same in the auto. I can go to the edit page and edit anything on the machine. I've got the retract still going. So we're only coming an inch above our mute. I'll go back and take my retract out. Change my open to bending speed. I'm going to take this down to 0.1. So you can see the difference in bending speed. I'm also going to go to 45 now. So the machine's calculated. On y-axis penetration, you get a 135 or a 45. Decompression's figuring, dwell time. So I've taken my bending speed down to 0.1 so you can see the difference. I've also went to a 135 or a 45. So I can just walk up and bend a part at will. I don't know if I got the right tooling. Well, that's bending speed. I'm going to show a decompression. I'll go back and program in a 90. So I've got a decompression 0.1 distance. Change that to 0.4 so we can see the change. And we're seeing decompression speed here. I've got my bending speed slowed down again still. Now I'm going bending speed for decompression. Dwell time. to the bottom, so if I had to catch a crane or a big panel or something, just 8 seconds, you can see it. But I'm also going to take my minion speed back up. I've got to dwell, so if I'm bending apart, see, it's counting. I put a long dwell in it, 8 seconds. That's pretty much the manual screen. Everything about this machine.